Hello everyone, I am Maurice. In today's class, we are going to discuss the sine magnitude binary. Let me take, for example, if I have a number like 8, if I have a number like 8, and then this 8, I want to change it to binary. Remember, to change it to binary, we can use a 4-bit system whereby we have this one being 2 raised to power 4 then minus 1, which gives us 2 raised to power 3, which is equivalent to 8. So in this case, I can have the first one, which is 1, 2, then 4, and then 8. So now, from here, I can take the two numbers that I can add to get 8, which is automatically 8. So where I have it, I just press 1, and then here I have 0, 0, and then 0. So 8 in binary is the same as 1, 0, 0, and 0. So now, what if I wanted to represent a negative 8? A negative 8, a negative 8, a negative 8. So how can I represent it? So a negative 8, I can use maybe 5 bits. I can use a 5 bits to represent this negative 8. And to represent it using a 5 bits, remember this one is the same as 2 raised to power 5. Then I subtract 1, and then this is equivalent to 2 raised to power 4, which is a 16. So in this case, I'll have a 16, then I have a 8, I have a 4, 2, and 1. So which I can add here. I'll have this one being a positive, this one being a positive, this one being a positive 1 here. I have 1 there. Then I can have 0, 0, and 0, and then here 0. Remember the last bits there represent the sign. Then these other here, these ones are the binary equivalent of that number, and then this one is the sign, then this one is the magnitude. So if I was to represent negative 8, instead of I having 1 here, remember 0, this one represents a positive, and then 1, this one represents a negative. So instead of this, I'll have 1, 1, 0, 0, 0, and that one is equivalent to negative 8. It is equivalent to negative 8. So to confirm if it is negative 8, remember I can use this. So remember here I had a 16, then I had a 8, I had a 4, I had a 2, and I had a 1. So remember here I had I have said for the negative we could have taken 1, then 1, 0, 0, and then 0. So remember this one could be negative 16, then added to here the one that is here is a 8. So if you had negative 16 and 8, this one you get a negative 8, a negative 8, a negative 8. So that is how you can even decide to take other numbers, like maybe we have maybe 7, negative 7, and maybe some other number like negative 12 and negative 15. And let us try to counter check, we see if it is going to work. So let us use all these. We can use a 5-bit system, a 5-bit system. So, and this, you get this one being a 5 bits, it will be 2 raised to power 5 minus 5 minus 1, which is equivalent to 2 raised to power 4, which is equivalent to 16. So a positive 7, we can use this one to be 16. Then we have 8, and then we have maybe 4, 2, and 1. And here this one 7, we take a positive 7 first, and a positive 7 will be represented by how many digits here can we add to get 7? We can take the first one, which is represent a 1 there, and then 2 represent a 1, and then also say 4 represent a 1, and then the others remains a 0. So remember, a 0 last here represent the sign. So a negative 7 will be equivalent to, this is 1, this is 0, and then we have 1, 1, 1. So remember the last sign here, we have said the last bits there represent they represent the sign of the number. And then if you take the 12, if you take the 12 with the same format, that is 16, 8, and then we add 4, and then we have 2, and then we have 1. If you take that and represent, what can we add to get a positive 12 first? We need to have 8 and 4. So here we have 1, 1, and here we have 0, 0. And here the last one is a 0, of course, representing a positive. So the negative equivalent of it will be a 1, 0, 1, and then a 1, then a 0, a 0. And if you want to see if that one is true, you can test it. So that is how we can represent such. So let us try to separate to now minus using a 2-bit.